Good afternoon, everyone. Today, already we have discussed about the metals and non-metals, the first part, where we have discussed the physical and chemical properties of metals as well as the ionic bonds formed by metals with non-metals. Now, we are into the second part of it, that is the chemical properties of metals. Reaction of metal with oxygen. All metals except platinum and gold react with oxygen to form metal oxides, either at room temperature or on strong heating. Now the nature of the metal oxides which is formed, they are ionic in nature. So normally a question may be sometimes asked, why metal oxides are ionic in nature? The reason for this is that metals donate electrons from the valence shell to form positive ions. The donated electrons are accepted by the oxygen atoms to form negatively charged ions. So the positively charged metallic ions are held together by negatively charged oxygen ions by electrostatic force to form metallic oxides. Again, it is normally asked, what is the nature of metal oxides? Metal oxides are basic in nature. Now let us go for the reaction of some metals with oxygen. First, let us see how potassium metals react with oxygen and water. Potassium, if you leave it exposed to air, it will start reacting or it will start getting oxidized by itself. But if you heat it gently, it will burn with a crimson flame. When potassium is kept in open air, it gets rapidly oxidized to form potassium oxide. You can see the reaction given below. K plus O2 gives K2O. This potassium oxide, when it is dissolved in water, it forms potassium hydroxide. And potassium hydroxide is an alkali. So what are alkalis? Alkalis are those bases which are soluble in water. Example, sodium hydroxide, potassium hydroxide. Similarly, if you see how sodium reacts with oxygen, or if sodium is heated gently in oxygen, we'll get sodium oxide, and which burns with a golden yellow flame. Similarly, that sodium oxide, when it is dissolved in water, it forms the respective sodium hydroxide, which is again an alkali. Reaction of magnesium metal with oxygen. Magnesium metal does not react with air or oxygen at room temperature. But when magnesium is heated in a flame, it catches fire. So magnesium burns in air to form magnesium oxide. So Mg plus O2 gives MgO. So MgO is a basic oxide. Remember, it is not an alkali, but it is simply a basic oxide, because if you dissolve it in water, it will not dissolve, or it is not completely soluble in water. Similarly, zinc metal reacts with oxygen to form the respective zinc oxide. Iron metal reacts with oxygen to form the respective iron oxide. But remember, iron has to be heated to a very high temperature, then only it will react with oxygen to form iron 2,3 oxide, that is ferroferric oxide. Fe plus O2 gives us Fe3O4. Fe3O4 is iron 2,3 oxide or ferroferric oxide. It is basically a mixture of FeO, that is iron 2 oxide, and Fe2O3, that is iron 3 oxide. Reaction of copper metal with oxygen. Copper metal does not catch fire even on strong heating. However, if you on prolonged heating, it slowly oxidizes to form a black color copper oxide, CuO. So what are basic oxides? The oxides of metals that react with acids to form salt and water as the only product are called basic oxides. You can take one example, sodium oxide, Na2O, reacts with HCl, which is a dilute acid, or say hydrochloric acid, to form NaCl, that is common salt or sodium chloride, plus H2O. Again, what are amphoteric oxides? The oxides of metals which react with both acids as well as bases or alkalis to form salt and water as the only products are called amphoteric oxides. Example of amphoteric oxides are zinc oxide and aluminum oxide. Action of metals with water. Different elements react differently with water. Some metals react vigorously with water, whereas others react with warm or hot water or steam. It all depends on the activity series of metals. So what is activity series of metals? The arrangement of metals in the decreasing order of their chemical reactivity is called the metal activity series or reactivity series. So we know potassium is the most reactive metal and platinum is the least reactive metal. And how do you remember? You remember the phrase like this: popular scientists can make a zoo in the low humid country more satisfactorily. Popular potassium, scientist sodium, can calcium, make magnesium, aluminium, zoo zinc, in iron, the tin, low lead, humid hydrogen, country copper, more mercury, satisfactorily silver, and gold and platinum. So potassium, sodium, calcium reacts vigorously with cold water to form the respective hydroxide. So they are in the top of the reactivity series, so they react vigorously with cold water to form the respective hydroxide and liberate hydrogen gas. Aluminium and zinc, they do not react with cold or boiling water, but they react with steam to form the respective oxide. Remember, they form the respective oxide, not hydroxide. Hydroxide is formed by potassium, sodium, calcium. Below that, when it comes to even magnesium. But below that, when it comes to aluminium and zinc, they form only oxide. Magnesium, again, does not react with cold water, but it requires boiling water. It reacts with boiled water to form magnesium hydroxide. Iron, only when it is red hot, it reacts with steam to form iron 2,3 oxide, that is ferroferric oxide. Copper does not react either with cold water, hot water, boiling water, or even with steam. Reaction of metals with dilute acids. So to understand these dilute acids, let us understand some mineral acids. What are mineral acids? The three basic common or very common mineral acids: sulfuric acid, hydrochloric acid, nitric acid. Most of the reaction when we talk about mineral acids, it only takes place with hydrochloric acid or sulfuric acid, but not with nitric acid. Now, among all the three acids, the king of chemicals is sulfuric acid. What is aqua regia? Now we know about three mineral acids, very, very strong acids, but the strongest acid is aqua regia. They even say that if you have a drop of aqua regia in your palm, it will make a hole and come out from the other side. So aqua regia is a very, very strong acid. So what is aqua regia? It is a mixture of 3 parts of hydrochloric acid and 1 part of concentrated nitric acid. Now, all metals reacts with mineral acids to liberate hydrogen gas. But however, nitric acid does not react with metals to liberate hydrogen gas. The reason is it is a very powerful oxidizing agent. It oxidizes the hydrogen formed and instead liberates nitrogen dioxide. Sodium, potassium, magnesium reacts violently with dilute acids to form the respective salt and liberate hydrogen gas. Few reactions are given. I'll just say other than this, say suppose sodium reacts with sulfuric acid. It will again form the respective salt. What is the respective salt? Sodium sulfate. So Na2SaSO4 and liberate hydrogen gas. Well, the hydrogen gas will be H2. You can mix and match and see the salt which is formed. Similarly, aluminium, zinc and iron, they also react with the mineral acids to liberate hydrogen gas, but not as violently as that of potassium or sodium. So zinc, suppose say again reacts with sulfuric acid. What will happen? So ZnSO4, zinc sulfate plus H2. Suppose iron with hydrochloric acid, Fe plus HCl. So FeCl2 plus HCl plus H2. It will liberate. So you can mix and match. No need to just follow this. You can see any reaction which comes and you can just do it by yourself. What about copper? Copper does not react with dilute mineral acids. It does not show any reaction with any of the mineral acids. Thank you.